So here we are. I'm just starting with a baseline, and I put a little dot here. It might be a little bit difficult to see, but I put a dot right there. That's going to be my center. That's going to be my vertex. So I'm going to start by just making that 90-degree angle straight up. You can definitely don't have to start this way, but this is the way that I did it in my example, and I'm just kind of recreating that. So I got that lined up. I got my protractor lined up properly, so I'm just going to draw that line straight up. Remember, on yours, you're probably just going to put a dot here and then move your protractor away and use your ruler. On mine, I can just kind of draw right over this, so that works out well for me. So I'm going to draw this line up here to this point, and I'm actually going to make my top line here as well. So again, you don't have to do this. You can start by just building out triangles. But if you're starting with a center 90, it might not be a bad idea to just build your two top lines. All right, so now I've got a 90-degree angle on the bottom, and see, I can mark this here. All right, so now if I draw straight across those two lines, I'm going to end up with a 90-degree angle right at the top too. So line it up as best as I can, and there we go. So now I've got a top line, I've got a bottom line, and on the bottom, what I'm going to do is I'm going to choose a set distance here. So if you remember, what I'm kind of modeling here is I'm going to make my first two triangles look like this. And now I already made this angle 90 degrees. Whoops. Got caught up on my ruler there. So I made this 90 degrees. And what I'm basically doing is I'm going to construct these first two triangles, this one over here and this one over here. I'm going to construct them so that I know that they're congruent using the side angle side congruence theorem. Because this side is going to be congruent to itself. I've got a 90-degree angle, then I'm going to make this the same length on both sides. So let me just build that out, and then we will be able to see. I'm using slightly different numbers on this side than I did in my model, just because it's going to work out a little bit nicer for me here. Make sure I line my ruler up as well as I can. Just going to put a little dot out here. I'm going to end up actually going at 1.5 here. 1.5. And then I'm just going to connect. Let me use my ruler here to line things up. And you may want to do this on yours as well, where you just kind of draw the lines longer than they need to be at first, and then you can kind of go back and erase a little bit. Trying to line this up. Again, like I said, my tools can be a little bit tricky here. Of course, this doesn't want to go where I want it to go. Okay, that's going to have to be good enough. So I'm drawing through that top line, but I can go back and I can erase a little bit later if I need to. Again, what's really important is that we're just lining up as carefully as we can. So there we go. And honestly, this looks a little bit off up here, so hopefully you can be more careful than I can with the tools that I have. So I measured this length to be 1.5. 1.5. So now here's what I'm talking about. I've got two triangles completed. I've got this triangle here and this triangle here. I know this side is congruent to itself. Actually, why don't I just put some labels on here? That'll help us name things and talk about them a little bit more clearly. So what I'm naming right now is the intersection, the vertices, right? So this intersection is point A, this intersection B, C at the top, D over here. So what I've done is I've constructed this triangle A, B, C, and ADC. Right, these should be exactly the same as long as I was careful and I measured everything as closely as I can, because I've got side, angle, side matches up with side, angle, side. Okay, and that's exactly what you're going to document in your paper over here. And that's what I did down here. So you can see an example. If you look on the document here, you can see now we've seen how we constructed these two triangles, what rule that we used, and then recorded those rules down here. So let me continue on a little bit here with the actual drawing. Okay, so again, since I constructed these two congruent with side angle side, I also know now that this angle has to match up with this angle is going to match up with this, and this side is going to be congruent to that side. And I can use that in building, constructing further triangles as well. So let me just kind of continue to build out here a little bit. So if I'm going to start my next one, let's see if this thing will line up for me. So it should be true if I was really careful. Let's look here. So this angle looks like it's about 51 degrees. Okay, this is where things have been not wanting to line up for me. Yep, and of course it's doing it again. So we're right about the same, about 51 degrees if this would level off on the bottom. Those angles do appear to be the same. Okay, so on my diagram, what I did is I now made a, there we go. I now made a 60-degree angle right here, right? So I made this angle down here 60 degrees. And so I want to show you a way that you can do that. You could obviously line the bottom edge of the protractor up with this, but we can also just count, right? If I'm at 51 here and I want a 60-degree angle, 51 plus 60 is 111. So I can just go, I could make my mark at 111. In my case, since I can draw right over it, I'm just going to do that. Okay, so line that up with 111, and now I've made a 60-degree angle. So I know this right here is 60 degrees, and I'm going to go ahead and do the same thing on the other side, and then we'll talk about that second triangle real quick, and then that should be it. Things should be coming together here pretty nicely, if I can get this to line up, which, like I said, sometimes it just doesn't want to do. Oh, it did for a second there. Come on. Okay, this is going to have to be good enough for me. So right now, this one's at 50. I know it should be at 51 if it would line up straight on the bottom, but it's at 50. Notice now I'm having to use these inside numbers, so make sure you do that when you're, depending on the size of the angle, right? Because I'm measuring this angle right now, and it's not 130, it's 50. And if I add 60, I'm going to end up at 110. So I'm just going to draw that angle. Again, it's okay if I go over, because I could just erase it later. Okay, so these are the second triangles that I drew. I think I labeled this intersection E and intersection F. And I made this 60 degrees. So it should also be true, I can measure these angles up here, and I should be able to say that now I've got these two triangles congruent by angle, side, angle. Matches up with angle, side, angle. And again, I know that these two sides should be congruent to each other because I know that these entire triangles are congruent because I built them that way. So I've got 60 degrees. Bring my protractor up here just to confirm these couple angles. If I can get this thing to sit flat again, we should be able to see. doesn't want to quite, come on, line up. Of course, once again, it doesn't want to line up quite perfectly. Okay, but if we're reading our protractor here, this angle looks like it's about 51. And over here, got the same. This angle does read like at about 51. So this is good. They match up pretty close. What I'm going to be looking for in your drawings is that they're anything that's supposed to be congruent is within 2 degrees of each other. And if you're careful, that should not be a problem at all in your diagrams and drawings. So 51, 51, and now we could say that I've got 2 additional congruent triangles. Okay, so we already talked about these 2 are the same, and since they are the same, by that side angle side rule, I know that I don't even need to measure this side because I know that they're congruent to each other because the entire triangles are congruent. And now I could say triangle CBE is congruent to triangle CDF by angle side angle. And if you were filling in your table, right, triangle CDE congruent to triangle CDF, remember that order matters. And if we're going to do, I'm running out of room here, but we're using the angle side angle theorem, and then we would just name those angles. All right, so ECB is congruent to FCD. And they are both 51 degrees. And then we've got our sides that are congruent. So CB is congruent to CD. And we don't have to measure those. Remember, you can, and you can put the measurement down there, but technically I don't have to because I already know those sides are congruent because they're part of these other triangles that we already made to be congruent. And so the little rule for that is corresponding parts of congruent triangles. Okay, those sides match up in those triangles that we already knew were congruent. We don't even have to give a measurement. And then list those final angles. CEB, oh, that's not right. CBE is congruent to angle CDF, and they are both 60 degrees. And then you just finish up. Just keep building out from there. Remember, you have to have a minimum of 3 pairs, so this is like 2/3 of the total work that you would need to have done. You can make it bigger if you want to. You would only have to show all the work and do the table like this for 3 pairs. So if you make something a little bit bigger with additional angles, you don't have to show all the work for this, but you could end up making some really cool stuff.